as promised, here is a video version of the quiz review worksheet. So for those of you who are looking at the review sheet answers and you're still a little uncertain about how to go about doing the problems, hopefully this will give you some idea of what you should be looking at. Questions 1 through 3 ask you to determine whether each function is linear or quadratic. Remember, the definition of a quadratic function means that its highest degree will be to the second power. So it can have x to the first power, it can have a constant, so it can look like ax squared plus bx plus c, could look like just ax squared, could look like ax squared plus c, but it won't have a higher degree than squared, and it will always have ax squared in it. Otherwise, it's linear. So let's take a look at the first one. You have to distribute this negative sign inside the parentheses. So we have y is equal to 2x squared minus 3x plus 5. There's my squared term. I don't have any value higher than that. That makes this quadratic. Next, I can just look at it. I see I have x squared minus 7, so I know that that is also a quadratic model. The last one, I have to distribute the negative 7 inside the parentheses. It's going to give me g of x is equal to negative 7x plus 14. It doesn't have a squared term, so I know that that is a linear function. Okay, number 4, 5 and 6 asks you to identify the vertex and the axis of symmetry on the parabola. Remember, the vertex is that minimum or maximum value. So you're looking for where that curve actually makes the turn. So here it's going to be at 0, minus 4. Then the axis of symmetry is that x-coordinate. Remember to write that as x is equal to 0. It's a line. It's a vertical line. Don't just say 0. Don't give me the ordered pair. It's a line. X equals 0. Number 5, the vertex falls at negative 1, negative 4. That means my axis of symmetry is at x is equal to minus 1. Number 6, my vertex falls at 0, 4. And the axis of symmetry will be the y-axis at x equals 0. Okay, then looking at questions 7 through 9, says the graph of each function contains the given point. Find the value c. Well, the given point is a value xy. So all you need to do for these problems is substitute those values of x and y into this equation and solve for c. Y is equal to 3, x is equal to 0, therefore c is equal to 3. In number 8, y is equal to negative 14, x is equal to 2, therefore I have minus 14 is equal to negative 10 plus c. Add the 10 to both sides, and you'll get minus 4 is equal to c. Oops, actually, let me erase that one. I just looked down. I forgot to write squared, so erase that one. We're going to do that one again. I have negative 14 is equal to minus 5 times 2 squared plus c. So I have minus 14 is equal to 2 squared is 4. 4 times negative 5 is going to be negative 20 plus c. Add the 20 to both sides, and you'll get 6 is equal to c, or c is equal to 6. Number 9, I'm going to substitute a 1 in for y. I have negative 3/4 times 3 squared plus c. 1 is equal to negative 3/4 times 9 plus c. That means that 1 is equal to negative 27/4 plus c. Add the 27/4 to both sides. So you'll have 1 plus 27/4 equals c. To add those together and keep it an improper fraction, 1 will become 4/4. So you have 4/4 plus 27/4, which is 31/4. So your value of c is 31/4. Let's take a look at question numbers 10 and 11. 12 and 13, they're all the same. It asks you to label the vertex and the axis of symmetry, determine if the function has a maximum or minimum value, and state that maximum or minimum value. So for these type of problems, where my equation is in standard form, not vertex form, but standard form, I have to use that x is equal to minus b over 2a, and y is equal to the function, or actually let's make that function notation. Let's write that as y is equal to f of minus b over 2a. And that's my ordered pair for my vertex. It's important that you remember that minus b over 2a gives you the x-coordinate of the vertex, also the axis of symmetry. So let's find that first. The x-coordinate of the vertex is minus b over 2a. So I go up to my equation. A is equal to 1, b is equal to 2, c is equal to 1. So I have minus 2 over 2 times 1. It's going to give me an x-coordinate at minus 1. To find the y-coordinate of the vertex, I'll substitute that negative 1 in. So y is equal to negative 1 squared plus 2 times negative 1 plus 1. So y is equal to 0. I have a vertex then at negative 1, 0. So here is my vertex. If I have my vertex, I know that the axis of symmetry is the x-coordinate, so x is equal to minus 1. So I can sketch in my axis of symmetry through the vertex. Then I have to find my y-intercept. That helps me sketch that graph in. So on my y-intercept, remember that's when the value x is equal to 0. So my y-intercept is at the point 0, 1. I can then get a point of reflection about that axis of symmetry. So on the opposite side, I can put that point in, and then I can go ahead and sketch my graph. Because it opens up, I have a minimum value. So we're looking on the y-axis. Think about this. On the y-axis, how low can that function go? What's the lowest value of that function on the y-axis? And that's going to be at 0. So I have a minimum value of 0, and that would be at -1. The minimum value is the y value. It occurs at -1. So let's take a look now at number 11. Number 11, I have my x-intercept, or my x-coordinate, not my x-intercept, sorry about that. My x-coordinate at -b/2a. A is equal to -1, b is equal to 4, and c is equal to 1. That means I have -4 over 2 times -1, which is going to give me the x-coordinate of my vertex at 2. Then to find the y-coordinate, I'll substitute that in, minus, and then in parentheses, 2 squared plus 4 times 2 plus 1. That's going to give me the y-coordinate at 5. So my vertex is at 2, 5. So there's my vertex. My axis of symmetry then is at 2. So I can sketch that in. My axis of symmetry, I'm going to abbreviate that, is x is equal to 2. My y-intercept then, so I'm going to take my function, y is equal to negative, substituting a 0 in for x. That's going to give me my y-intercept at 0, 1. I now have a point of reflection across that axis of symmetry, and I can go ahead and sketch in that graph. This opens down, giving me a maximum value of y. The highest point it can go is going to be 5. So the max value is 5. And I think I will end this video here. I will begin another video with problem number 12.